s raised to the power of 4. You want to solve everything in form of theory. Now, what are you going to do? Then, they are now asked to find the y, the x. What will now be the y, the x? You call this one, you said let u equals to 8x plus 2 all raised to the power of 4. Y now equals to cos u. So if I find du dx, du dx, du dx, we give me what? We give me 4 into bracket 8x plus 4, 8x plus 2, all raised to the power of what? All raised to the power of 3. All raised to the power of 3. You subtract 1 from this. Now differentiate the bracket, you have 8. So from there, what are you going to have? If you differentiate this, you have dy dx equals to dy dx u, dy du equals to cosec square u. This is what I'm going to have there. Therefore, dy dx equals to du dx times dy du. So what's our du dx? Our du dx is 32 into bracket 8x plus 2 all raised to the power of 3 cosec square u. What's our u? Something is our u. 8x plus 2 all raised to the power of 4. So because this is our initial u, that's what you said let u equals to. So this is what you do when solving objective questions. If you don't get it, rewind it again, watch it and over again, you get what we are saying. So that is dy dx. So all the trigonometric function we mentioned, that is how to solve them. But we could only mention inverse function of trigonometry. We only mention 3 parts, and we mention 1 part for power of trigonometry. For example, let me just solve one question under power of trigonometry. Square x. You can see that this is a power now. We are having 2 as the power. Then find dy dx. Find dy dx. We could only show the theory here. So if y equals to sine square x, so what will now be our dy dx? So you can write it to be solution. We have y equals to sine x all squared. That is what we are saying. So you call this one u. You said let u equals to sine x. So y now equals to u squared. So if you find du dx here, du dx will give you cos x, du dx will give you cos x, dy du will give you what? 2u. So what are you going to have from there? Dy dx, dy du. So what's our du dx? Our du dx is cos x, and our dy du equals to 2u. So if I do, you have 2 cos x. What's our u? Our u equals to sine x. Beautiful. We're having 2 sine s cos x. So 2 sine s cos x in trigonometry, when we are talking about 2 sine s cos x, that is addition formula of sine 2x. Sine 2x. Let's quickly play with that. Let's quickly play with it. This is what you are going to have. We have sine x plus x. So if you have sine a cos b, what is it going to give us? Sine a plus b. It will give us what? Sine a cos b plus cos a sine b. So if you now have sine x cos x, this is the formula from trigonometry. You go to have sine x cos x, sine x cos x plus cos x sine x. It's like you are saying this thing is a product. If you have 2 times 3 plus 3 times 2, both of them will give you 6 plus 6. So if we now say this and this, they are the same thing. So since they are the same thing, I can write them as what? 2 sine x. I can write them as 2 sine x. We can write them as what? As sine 2x. That is why we are saying. So you know that we are having sine 2x, sine s. So this one will now give us what? 2 sine s. This one give us 2s. So this one will now give us 2 sine s cos x. That is what we are going to have. So we quickly derive that from trigonometry. So let's inverse of x. If y equals to sine inverse of x, sine inverse of x. When you're having sine inverse of x, what's going to give us? How do we get 1 over square root of 1 minus x squared? So let's quickly play with it. So we said y equals to sine inverse of x. So that means I'm saying x equals to sine y. So x equals to sine y. So if x equals to sine y, if you differentiate, you have dx dy. Dx dy will give us what? Cos y. Dx dy will give us cos y. But recall, our determination is to get dy dx. So if I take the inverse of this, we have dy dx, that is multiplying both sides by 1. We have what? 1 over cos y. So we are going to have 1 over cos y. So if you are now having 1 over cos y, recall that sine square y, we have derived that today, plus cos square y equals to 1. So now we are now making cos the subject of the formula. We have cos square y equals to 1 minus sine square y. So if I take the square root, I will have cos. If I have this, I will have square root of 1 minus sine square y. Sine square y. But now we said sine y equals to what? Sine y equals to x. So that means I cannot rewrite this to be what? This is, I can substitute for this. So if I substitute for this, I will have 1 all over what? 1 all over square root of 1 minus what? Minus sine square y. But recall that our s equals to sine y. So now if I'm taking dy ds here, dy ds here, we give us 1 all over square root of 1 minus s squared. Since s equals to sine y, so I will just substitute for what? For here to be x. So I put it here, we will have what? 1 over sine y. So that is inverse function of what? Of sine. So this is inverse function of sine. So let's now see inverse function of cosine. If y equals to cos inverse of x. So now we have, that means we are saying s equals to cos y. So if I take the y there, the x dy will give us what? Will give us minus sine y. To give us minus y. But our determination is to get dy dx. Dy dx will now give us what? Will now give us 1 all over, because if you take 1 over this, will give us dy dx, will give us 1 minus sine y. But our determination is to get what? Is to get that. So from you recall that in trigonometry we says that cos square y plus sine square y equals to 1. So now if cos square y equals to sine square y equals to 1, so I want to make this the subject of the formula. We have sine square y equals to 1 minus cos square y. So finally I have sine y equals to square root of 1 minus cos square y. So now let me come back and substitute for this. Now if I substitute for this, I will have what? Dy dx equals to 1 all over the, so the minus that reflected will come up 1 over 1 minus cos square y. But now let's substitute for this. So we have dy dx equals to minus 1 all over square root of 1 minus s squared. So the difference between sine and cos is that this one is having a negative. So lastly, we have inverse function of tan.